Alright, so the final thing that I want to talk about in the perimeter series is arc length. But before I go on and explain what arc length is, I want to talk a little bit more about properties of circles. So if I draw a circle here for you, I know in the previous slides or in the previous videos I spoke about diameter and we talked about the circumference formula with regards to diameter. But I haven't introduced you yet to radius. So if I just introduce you to radius first. Now the blue line, this represents the diameter of a circle. Okay, so that diameter is the line that cuts straight through the center of the circle from one circumference to the other circumference. But what radius is the distance from the center of the circle to its circumference. Okay, so from the center of the circle down to its circumference. This distance is called the radius. Now, generally speaking, the diameter is twice the radius. Okay, if you want to write it with regards to radius, the radius is the diameter divided by 2. Okay, so you've got these two concepts, a formula now for diameter and a formula for radius. When we were discussing circumference, I gave you the formula for the circumference with regards to the diameter. So I gave you this formula, C equals pi d. Okay, so we've now got the circumference formula with respect to the diameter. But now that we know what the diameter is, we can write it with respect to the radius. Now, knowing that d is actually equal to 2r, this d over here can be now replaced with the 2r. So we can write a different formula for circumference, and that is c equals pi times 2r. Alright, so now we've got two different formulas for circumference. Now this second formula over here, this is the important formula that's used for working out arc length. Alright, another definition I want to give you before I move on to the arc length formula is something called a sector. Okay, we need to talk about what a sector is. I'm going to show you on this circle over here what a sector actually is. Now if I slice my circle down these two radii and around this part of the circumference, this shaded region here, this makes what we call a sector. Okay, so if I take that piece out over here, this is now my sector. So if we want to define what a sector is, it's basically just a slice or a portion of our complete circle. If we slice our sector straight down our two radii, cut it straight through, pull it out, this is now what we call a sector. Now if I draw around my circumference in red over here, what this red line makes is now what we call our arc length. So this is what we've been talking about, or what we've been leading up to with regards to all of this. So now we know our arc length, and it's defined by the letter L. So we've almost covered all of our definitions here. The last thing I want to talk about is this little angle here. Every sector, as well as having an arc length, has got an angle here that's defined by this little symbol here called theta. If you can't see it, it's not very clear on that diagram, but it is this symbol here, it's called a theta. Okay, this is a Greek letter. Generally, theta is used to describe an angle in anything. Angle in a triangle, angle in this case a sector. So whenever we're dealing with angles in maths, we look at the Greek alphabet, theta, beta, alpha, all of those different things. But theta is the general term used to describe an angle. So in this whole video, we've talked about definitions. We've talked about arc length, we've talked about radius, we've talked about a sector, we've talked about a theta. In the next video, I'm going to put all of these definitions together, and I'm going to start discussing and showing you how we actually come up with the arc length formula.